All right, guys, we're going to go ahead and get rolling on this packet today. Um, so I know we had a delay, but we need to kind of get rolling in this thing, and I'm going to have you watch a video and fill it out, and then and go from it from there. I don't know what kind of homework we're going to get into just yet. So anyway, everybody should have a packet, so follow along with me. And data can be described as a collection of facts. Okay, facts. We're going to talk about statistical questions and data. For example, numbers, measurements, observations, and descriptions. We have two types of data. We have categorical data and numerical data. Okay. Categorical data, this data represents characteristics. Okay. All right. And is often sorted into groups. Categorical groups. Numerical, this data represents values that can be measured. Okay. So categorical groups, numerical measured. All right. All right. So let's continue on. So we're just going to talk about a couple of these just because of the timing of it. But it says read each statement, determine referring to if it's categorical or numerical. Let's start with Luke. Luke, I am collecting data to determine each student's favorite genre of books to read. Is this categorical or numerical? All right. Well, to me, when I look at this, all right, this is an example of categorical data. All right. Why? All right. Because the responses of the genres. All right. So to be categorical, we have to have in groups. This data represents characteristics, that is often sorted into groups. We have different groups of genre. So I'm just going to write categorical and I'm going to abbreviate. Let's move on to uh, Demarcus. Demarcus, I am collecting the data to determine how many hours of sleep each student in our class gets. This would be an example of numerical because we can measure how many hours each person gets. We can get a number. All right. So over here it was a group. We were putting them into groups. Here it's measured. Let's go to Josie. Josie, I am collecting data to determine how much money each student's family spends on groceries each week. Each week. All right. So, can we measure how much they spend each week? Yes, it is absolutely numerical. If it's measured, it's numerical. One family spends 150, the other one spends 500. I just went to Sam's Club and it hurt. It was a lot of money. So, we can measure how much we're spending on that. Last one is Heather. Heather, I am collecting data on the color of cars that run the stoplight in front of our school. All right. I'm collect that run the stoplight. So we're going to put those folks, all right, the color into a group. So that is categorical. Categorical. Okay. So just real quick, just wanted to introduce numerical and categorical data. Let's flip it over, all right, and talk about what the meat of this lesson is. It's called statistical questions. Okay. In order for a question to be considered statistical, it must meet two criteria. The first criteria is the question must be able to answer by data. All right, it must be data driven, has to have numbers, has to have input, and the data must vary. It must vary. So essentially, if we look at this, it has to have more than one answer to be a statistical question. So instead of coming up with this, let's come down to task 3 and take a look at this. Okay, task 3. It says, use your understanding of statistical questions. All right. So, statistical question has more than one answer to complete the table below. Then write your own statistical question. All right. Well, let's just talk about these four. Okay. What is the favorite restaurant of the students in my school? All right. What is the favorite of the students, plural? So is there going to be more than one answer to that? Yes, there's going to be more than one answer. I like Applebee's. All right. Joe might like Red Robin. All right. Elise might like McDonald's. So that is absolutely a statistical question. Why? Has more than one answer. It's driven by data. The data is from the folks. The next one. How many years have the students on my school soccer team played sports? All right. So when we look at this, how many years have they played? Well, that's just one answer. I'm sorry. Sorry about that. I apologize. How many years have the students? It's more than one student. So it's going to be more than one answer, right? So it is absolutely statistical. I apologize. Yeah, because I played 5, Lynn played 7, Derry played 13, and so on down the line. Statistical, more than one answer. Number 3, how many siblings do you have? How many do you have? 1, 3, 4. You. This is the key here. You. It's singular. How many do you have is one answer. So it's not statistical. Sorry. It's not statistical because it only has one answer. How about the next one? How many pets does Mrs. Jackson own? Mrs. Jackson's one person. She owns 3 pets. Again, not statistical because it only has one answer. Okay, and this is what we want to focus on. A statistical question has more than one answer. All right, a non-statistical does not. It has one answer. All right, let's continue on. Okay, and let's take a look at the homework real quick here. So you're going to go to your homework packet, okay, and we're going to talk a little bit about these. All right, because we need to see what is statistical and what is not. I just want to kind of do these ones with you and then jump to the next deal here, okay? All right, let's go. How often do you play football? All right. Is that a statistical question? No, it's you. It's singular. So it's not statistical. If I wanted to make that into a statistical question, I would say, how often do the 6th grade students play football? So I've changed the subject to 6th grade students. Now there's more than one answer. Okay, we're not going to do all of these, but we're going to kind of slide down through here. Number 4. What are the types of sneakers students in our school wear? Is that statistical? Is there more than one answer? Is the subject plural? Yes. So it is statistical. Absolutely. There's more than one answer. Let's take a look at number 5. How many students tried out for the volleyball team? More than one answer? No, there's only one answer. So, how many students we have how many students, but how many tried out for the volleyball team? 4 did this year, 6 did last year, 18 did the year before, right? There's only one answer per year. So, number 5 is not a statistical question. So, they kind of tricked us there a little bit. That was usually a giveaway to give us a statistical question, but here it changed up. So, you have to be careful. Let's take a look at number 6. Number 6, how many meters can the students on the swimming team swim? So, how many meters can the students on the swimming team swim? All right, well, student 1 swim 30, student 2 swim 100, student 3 swim 400. Are those all different? Yes. So that is a statistical question because there's more than one answer to it. Okay? Let's slide down to number 7. And I skipped these two just to save us a little bit of time. Don't worry about those. What is the maximum number of minutes that students on the track team can run? Is that a statistical question? What is the maximum? Students. Well, everybody's different. I can't run very long, so my number might be 10 minutes. Brian's might be 30 minutes. Miss Rehack's might be 40 minutes. Mrs. Hoovie's might be 15 minutes. So we have multiple answers to that question. So it is a statistical question. Statistical. Okay. We're going to do 2 more as we talk through this, and we're going to jump to the next lesson. How many pairs of tennis shoes do the students in our school have? How many pairs? Well, that's an easy one. Everybody has a different amount. To me, I have a couple. All you folks probably have 5, 6, or 7. So that is absolutely a statistical question. Okay. And then the last one, number 9. How far can the sixth grade students jump in the long jump? How far? I'm sorry. How many students in the sixth grade can do the long jump? All right. Well, how many can do the long jump? Well, that's just one answer. So that is not statistical. It's not statistical. And I was reading my sample at the beginning that made it statistical. So I'm going to make this. Why is this not? Because it's one answer. Only one answer. How many people can in sixth grade can do the long jump? 45. That's it. That's one answer. But now I can change that statistically. Watch. How far can the sixth grade students jump in the long jump? So now I've varied the answer for each one because generally, all right, everybody jumps a different length. So when it's statistical, it is more than one answer. When it's not statistical, there's only one answer. Okay, and I just wanted to talk to you about that. All right. Okay, we're not going to do those. We're going to go back to the next packet. Okay, and we're just going to talk about a little bit of data display here. Okay, I know it's a lot. It's a 2-hour delay, but we've got to keep rolling. All right, so I'm back in this packet. If you notice, this is the student handout packet. Okay, make sure you put your name on that in math period, and let's get rolling with this. Okay, so we're going to do the front. Okay, we're going to do this side, and then your homework's going to be out of the homework page. All right, let's go to work. Data can be displayed in various graphs, including dot plots, histograms, box plots. We're going to learn about all those. Dot plots are useful for showing center, right? Where the center is, the measures of center, and variance, right? How it varies. The variability or spread in the data points describes how far apart the data is from one another. This can be represented by the range. The range. Variability or spread is the range. Remember, big minus small. We talked about that. Center. Okay. The median and the mean both represent the center of the data. When the data is skewed, then the median, right, MEDIAN, is the best representation of the data. When there's an outlier, we want to use the median. When it's skewed right or skewed left, we want to use the median. It just doesn't give us a good fit, okay? When the data is symmetrical, then we want to use the mean, right? So essentially, outlier median, no outlier mean. Think of it that way, okay? We've talked about that. Let's get rolling. All right, so let's talk about these a little bit here. At a doctor's office, the pulses of each patient are taken and recorded. The data is displayed. What is the lowest pulse? Well, the lowest pulse here is 64, right? 64 beats per minute. What is the highest? Well, that's pretty easy. 80 beats per minute. What is the most common heartbeat? What is the highest dot plot, right? Clearly it is 70. So this dot plot makes it easy for us, doesn't it? There's how many 70s? There's 6 of them. How many people had a pulse over 76? Over 76, not 76 and over, but over. Well, I only see one person. Okay, so reading this dot plot is important. How would you describe the general spread of the data? I would describe this as symmetrical. Now, if we go back up here and talk about this, symmetrical data has 2 equal sides. Now, does it have to be perfectly equal? No. And you're going to notice that if I drew a line down through here, this side would be pretty close to this side. We would consider this symmetrical. Even though they have a number as high as 80 there and 64 has 2, we consider this symmetrical. Now, let's take a look at this, the skewing aspects. when it's more numbers are to the left, it's skewed right, meaning that there's less values to the right. When more numbers are to the right, it's skewed left. And that's important for you to remember that, okay? So we would consider this symmetrical, right, data. Okay. All right, let's continue on the other page and let's get rolling. Hope you're enjoying the packets. Analyze the data in the dot plot, then complete the chart. Okay, well, let's take a look at it. Plot A, where is most of the data? All right, so let's take a look at this. First off, all right, where's most of the data? The most of the data is in 1 and 2. Look, there's where most of the dots are. So where's most of the data? 1 and 2. In plot B, where's most of the data? Well, most of the data is really 20 and above, or you had 20. So I would just write 20. 20 had the greatest number, right? How is the spread of the data? All right, is it clustered real tight over here? All right, like this one. If we look at this data right here, you see how this is a nice tight cluster, and really if we pull it down, you can see that it's clustered real tight. So we're going to call this very close data. Over here, the values spread out. They range from 10 to 24. So the data spreads out. It spreads out 10 to 24. Okay. All right, let's continue on. All right, is the data grouped around the left, the middle, or the right? All right, well, this here is grouped to the left, to the left. So we call that skewed right, but it's grouped to the left here, right? This over here is not grouped at all. There's nothing chunked in together. We're all spread out. We have a bigger range, big minus small, than this. So there is no grouping. It's not grouped. Okay. And what could this data represent over here? Well, it could represent anything. It could represent how many times people had hamburgers a month, how many times they had shrimp. Think of food over here. All right, this could represent your vegetables. Well, some people had vegetables 10 times a month, and some people had it 24 times a month. So these are going to vary here a little bit. Okay, but when I look at a dot plot, the easiest way to think about it is when we think about food. Okay. All right, let's scroll on down to um, a thing called a histogram. All right, and let's talk about histograms and what they are and how they work. A histogram is a bar graph that has data clustered, and you'll notice that these are clusters of data: 0 to 9, 10 to 19, 20 to 29, and 30 to 39. This is a histogram, not a bar graph. Now, a histogram also has bars of the same width. So if I got a measuring tape out, we would measure these. These are all the same width on the histogram. All right. So we can't get specific data from a histogram, but we can get good chunks of data. And that's important. Our frequency always comes up the side. So we're going to get more into this later down the line, but it's a histogram. The histogram showing the number of points scored in a game has what type of distribution? So here's the basketball points, all right? Where can most of the data be found? Okay, so the majority of the data found here is between 10 and 19, right? And most of the data can be found from 0 to 19. Most of the data can be found 0 to 19. Okay. Can we tell how many scored 9 or how many scored 10? No, but we can tell that there was a nice cluster of data. So our histogram right here, this is our majority of the data. Okay. Now, if we talk about skewing on our or histogram, right? Remember, if there's more information to the left, it's skewed right. So it's opposite. Height of pediatric patients. The histogram showing the height of the patients has what type of distribution? Where can most of the data be found? Okay. Well, the majority of the data certainly can be found from 45 to 55. Here's our chunk. Okay. So there it is. So 45 to 55. And it's going to be skewed left. Remember, it's opposite. It's skewed left. If there's more data to the right, it's skewed left. Okay. So that's a good start. You are actually going to jump back into the packet for your homework. And your homework's going to be homework 2, data distribution. Okay, so you'll have this page. Okay, and that's all. You have 1 to 8. This page. There is Khan Academy this week. Please make sure you get it done. Hope you enjoyed the video. Have a good day, guys. Bye.